Bright Tuty. Every student matters.
Here they're asking, can a polyhedron have its faces as three triangles? Can it have three triangles? No. Just to see why. In the first one, we discussed about the polyhedron for its faces as three triangles. So when we talk of the triangular pyramid, right? So its base will be a triangular. Its base will be triangular. And when we join these like this, so 1, 2, 3 and 1 at the bottom. So how many faces? Minimum 4 faces we have. In a polyhedron, minimum 4 faces we have. So it is not possible. So the answer is no. Then they are saying 4 triangles. Can we have 4 triangles? Yes, 1, 2, 3 and the bottom one. That means a triangular pyramid. Yes, it has. So yes, it is possible. Okay, a square and 4 triangles. So if we have a square, just to see, if I draw a square, suppose this is a square and we have to join them. So 1, 2, 3 and 4. So what are they saying? A square and 4 triangles. So one square that is at the bottom and 1, 2, 3 and 4. This is there. Okay, so is that possible? Yes, this is possible. So the answer for the third part is also yes. So the first one is no, it is not possible. Reason is we have minimum 4 faces. Can we have 4 triangles? Yes, in square pyramid we have 4 triangles, one at the bottom and 3 the sidewards. And then a square and 4 triangles, so we have drawn a square, and yes, the sidewards faces are triangulars. So there are 4 triangulars and 1 square at the bottom. The next question, they're asking, is it possible to have a polyhedron with any number of faces? Yes, it is possible, any given number of faces, but the minimum number of faces should be more than 4, because we have minimum 4, so it should be 4 or more than 4, then it is possible. Okay, so yes, you can think that yes, it is possible, but it is only possible when we have the number of faces more than 4 or 4, not less than that. Then pyramid will not be possible. Okay, so the answer is yes, if number of faces, you can write number of faces is greater than or we say equal to 4. Right? Okay. Next is they're asking which are prism among the following. So we know in the prism we have what? Top and bottom faces, or the polygons as identical, same. So first one is a nail. Is this even a prism? No. Why? Because it has this circular face, right? The second is unsharpened pencil. The pencil which is not sharpened, a pencil like this, I show you as it is drawn also. So this pencil will have the top and bottom as same. So yes, it is a prism. Okay. The third one, a table weight. Okay, will this be? No, because this is a pyramid if you see. Because in prism the top and bottom polygons are going to be same. Here it is a pyramid, it is not even a prism. So it will be no. Okay. A box, yes, it is a prism. The top and bottom we see are same. Right? So this is how we identify which are prism and which are not. Okay, the next question, they are asking in the first one, how are prisms and cylinders alike? So cylinder is what? Just if we talk of cylinder and prism, cylinder also have top and bottom as circular, right? So yes, we can consider that as a circular pyramid. Okay, or we can consider it as a prism having top and bottom bases faces as circulars. So we will say they are alike in the first part, as cylinder can be considered as prism with circular bases. Prism with circular bases. So base and top will be circular in shape. Okay, what about the second part? Second one, how are pyramids and cones alike? Like, so if I talk of a pyramid, suppose I have this triangular one, okay, where I am joining like this. So here what I have, the base is triangular, but in case of a cone I will have it like this, right? But I have this, the circular base we have. So yes, pyramid and cones are alike in the way that its base is circular. So pyramid, it can be called as a pyramid with circular base. So this way we can, compare them, they're alike. Okay, now moving on to the next part. Here they are saying, is a square prism same as cube? So square prism means the base is going to be a square in form. Okay, or we will just take a example of a prism which has a square base. Okay, let me take that out. So if we see here, this just to see the base is a square. Okay, the top and bottom is a square, consider them as squares. So if this length and this length, that means the height between these two, if that becomes same as this, then it will be a cube, otherwise it can be a cuboid also. So it is not always that the square prism will always be a cube. It can be a cube, it can be a cuboid also, right? So you will write that it can be a cube as well as it can be a cuboid. It can be a cube when the height between the faces, or I say the top and bottom faces, becomes equal to the side of the square. Then this is going to be a cube for sure. Okay, otherwise it will be a cuboid. I hope you understand the question. Next part, here they're asking us to verify Euler's formula. So what's Euler formula? F plus V minus E, it is equal to 2. So we have to verify it for both of these figures, right? Okay, so if we see the number of faces in this, so let us count the number of faces. 1, 2, 3, 4, and we will have how many at the back? Just see, when you join, one is at the bottom definitely, that is 5, and 2 at the back, because one will be formed with this line and this line when you join at back, that means this line and one more line, and one will be along this side. Okay, so how many? 1, 2, 3, 4, 2 at the back, that means 6, and 1 at the bottom, that means how many faces do we have? 7 faces. What about the vertices? So if we talk of vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I told you 2 at the back, so those 2 at the back will intersect at one point, that is the 10th one. So we have 10 vertices minus number of edges. So number of edges if we count, so let's take a different color and show it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now at the back also, right, we have 13. At the 13, one standing line would be there, that is 13th. The two faces will intersect at that point. I told you two faces are at the back, so those two faces will be joining with one edge. So that is one edge. So we have 13, and at the bottom like this 2 will also be there, right, with those two faces. Two sides will also be there, so total 15 we have. So 7 and 10 is 17, minus 15 is equal to 2. So for this case it is verified. When we add the number of faces and vertices and subtract the number of edges, we get it as 2. You need to imagine the figure, right, because they are 3D shapes, can't be shown on plain paper. Okay, now what about this one? So for this one we are going to talk. So let us first talk about faces. So how many faces will we have? Just see, this is 1, then at the back 2, then we have this one as 3, the front one is 4, 5, 6, 7, 8, right, and the bottom one 9. So how many faces? 9 faces we have. What about the vertices? Let's count the vertices. 1, 2, 3, 4, 5, 6, 7, 8. Right, so how many vertices? Let us count them again once. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 9. So we have vertices as 9. Now we are left with one more thing, that is the edges. So what about edges? Let us count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we have 16 edges. Okay, so let us add these two. 9 plus 9 is 18, and from this let us subtract the number of edges, that is 16. So are we getting 2? Yes, we are getting 2. So for this also we have verified it, right? So I would recommend you to draw these shapes in your notebook. Try to imagine the faces at the back also. Like in this case, we would have shown it with like this, with a dotted lines like this. So this would have been the face at the back, two faces at the back. Okay, so now after this, let's go ahead with the next one. So here we have to use Euler's formula to find the unknown. Now what's Euler's formula? It is F plus V minus E equals 2, or we can say that F plus V is equal to 2 plus E. So number of faces is not known, number of faces is not known in the first one, number of vertices is 6, number of edges is 12. So let us find. So 6 minus 12 will give us minus 6 equals 2. So F is equal to 2 plus 6, that gives us 8. So F is equal to 2 plus 6, that is 8. So number of faces is 8 here. So what would be the answer? 8. Okay, for the second part if we try. So here we have 5 faces. So 5 plus vertices we do not know, edges we know, and it is equal to 2. So 5 minus 9 is minus 4 equals 2. So V is equal to 2 plus 4, that is 6, right? 9 minus 5 is 4, sign will be of minus here. So what will be the answer? 6. For the third one, we have 20 faces plus 12 vertices minus edges equals 2. So 20 plus 12, you know how much is that? 32. Minus E equals 2. So 32 minus 2 is 30. So the number of edges is 30 here. Clear? So like this, using Euler's formula, if we know one of them out of the three faces, vertices and edges, we can find out the third one. Now here is one more question. They're asking, can a polyhedron have 10 faces, 20 edges and 15 vertices? How many faces? 10. So if it is possible, then it is going to satisfy the Euler's formula, which is F plus V minus E equals 2. So let us put the values in the formula and see if it comes out to be equal to 2. So 10 plus 20 minus 15. 10 plus 20 is 30 minus 15. What do we get? 15. It is not equal to 2. So it is not verifying the Euler's formula. So it is not possible. The answer is no. A polyhedron having 10 faces, 20 edges and 15 vertices is not possible at all to form. Is that clear? So we have learnt in this the 3D shapes, the difference between the prism and pyramid, right? And we have discussed, so what discuss the difference, that is in a prism the top and bottom faces are going to be exactly congruent, the same. So in prism, the top and bottom are going to be the same kind of polygons, congruent polygon, and the other faces can be parallelograms. And in the pyramid, we discussed that it can have square, it can have rectangle, it can have triangle, hexagonal base, it can have any base, but the sideward faces are always going to be triangular because we will join them to one vertex, one common vertex. And then we have discussed Euler's rule to verify whether the figures that we are thinking of are possible to form or not. Clear? So this is all there in the chapter. I hope the chapter is clear. In the first one, we discussed about the very first thing that we have discussed about the shapes and their views, the front view, side view and top view. Then we have discussed about the maps. Okay, we try to form the route from the home and school and like this. And in the third one, we have discussed about all this that I told you. So this is all for the lecture. I hope you understood it. So keep learning and thank you so much. Stay tuned for more upcoming videos. Thank you.